Hello my dear first PUC students, welcome to Deeksha Karnataka YouTube channel. And if you are following our channel, then you must know that we are obviously doing a lot for your final exam, and we have already done our all 1 marker, all 2 and 3 marker questions are done. So if you have not watched them, go and check them out. And today I am going to discuss the all important all 5 marker question. So in this video, if you watch this video, then definitely you will be able to score 3 derivations. Compulsory you have to answer 3 derivations of 5 marks out of 5. 3 derivations you have to do. 5 marks is there each question, that means 15 marks, and obviously you also have to answer 2 numericals. So those 25 marks students find a little tricky, because for first PUC there is no strict guideline as of now. So it is up to the colleges to decide what questions to give, what type of numericals to give. So that's why I have decided I will solve 10 very important derivations and 14 very important numericals. So only 24 questions that you have to do to get those 25 marks. Now in numerical section there is one disclaimer that exact questions, if you try to remember and memorize them, it will not be helpful for you. So you have to understand how a question is being handled, how a question is being tackled. Concept and formulas that you will use should be same. Only the values and the question language might change, so based on that you have to adjust and answer. Okay, all the derivations that I am going to do are very important, and I can guarantee you from my previous experience of teaching PU1 in the classes that the questions that I am going to discuss are very important, and you should get 3 derivations common from those 10 derivations. Don't try to make any adjustment. Practice whatever we are doing. Now in this lecture I am not going to discuss system of particles chapter. Many students find that chapter little difficult, so that's why I have skipped that. If you want system of particles chapter, then mention in the comment below. I will try to do a separate video only for system of particles chapter. Otherwise, as many students do not study that chapter and they eventually skip that chapter, I am not going to cover that chapter in our lecture. So worry not, all the derivations, all the numericals that I am going to solve today will be definitely be helpful for all of you in your upcoming annual exam, right? And I am not doing too many 100 questions, 150 questions, not like that. I am doing a very selective 24 questions in this session. Also I will be recommending all the chapters that you must solve numericals from. Okay, I will be giving you a list of chapters from where you should practice numericals other than the numericals that I am solving in this lecture, right? And also I will be doing a live session before your annual exam, so stay tuned for that as well. There we will be discussing all the questions live one-to-one, and if you join that live, you will be very beneficial that whatever doubts you might have, that also be cleared during that live session. Clear? Now let's start with the derivation. First, derivation number 1, derive the expression x equals to v naught t plus at square using velocity time graph. Now this question is directly taken from your model question paper, not model question, question bank. And in this case what is important is that in some cases you might face the same question with a slightly different language, that is s equals to ut plus there is a half, obviously half at square. Okay, you might face this question as well. And both of them are same. Okay, now first of all you have to draw a graph. Now based on your equation that is given, if it is s equal to ut plus half at square, which is obviously the same, instead of x we are using s, displacement, and ut is u is the initial speed. In this diagram we have used v naught, so in the particular case you have to show this as u. Okay, so that is the only difference. V is remaining the same. Okay, this is v. Now let us understand the graph. If many students do not understand the graph, they just memorize everything and try to replicate that in the exam hall, and they make small mistakes. So what is this graph all about? So when you draw the graph, obviously you have to draw the y-axis, you have to draw the x-axis as well. Okay, and your x-axis is basically your time axis. So time increases as you are moving in this particular direction. This is your velocity direction, so velocity changes as you are moving in this direction, and in fact if you are moving upwards only, then velocity increases, right? Now when the object starts, initially it has already have an initial velocity. It is not starting from zero. That part you have to understand. So it is starting with an initial velocity. So that initial velocity, we are saying this is the initial velocity. It's not zero. If it was zero at time t equals to 0, then the graph should have started from here, right? Because it already have an initial velocity, so your graph is starting from here. Okay, it is moving with uniform acceleration. So uniform acceleration means the velocity time graph will be a straight line. Uniform acceleration means velocity time graph should be a straight line. Now if it is starting from 0, the graph should be like this, because it has an uniform velocity, initial velocity, so it is not starting from 0. So that initial velocity, we are saying this. It can be v0, it can be u, based on the question. Now from here the object is moving with an acceleration, so because of that the straight line that you are drawing should start from here. The straight line should start from here. Okay, this represents your graph. So after some time the object reaches at some point, okay, and that final point is basically your velocity. That final point is your velocity. Okay, so this is your velocity. Don't worry, I will erase it. So this is your final velocity v. Okay, this is obviously the velocity time graph. So v is, in general, this v represents velocity. This v represents the velocity at this particular time. What is that time? So time axis, for time axis you have to draw a perpendicular to time axis. This is the time t, and during this time t the velocity starting from v0 increases to v. Okay, so this is how you should draw the graph. Okay, now in this diagram that is given in your textbook, they draw one more triangle over here. And why it is so? Because when you are given the velocity time graph, from this graph if you find the slope means take this angle and find tan theta of this angle. Tan theta is called slope of the graph. Okay, those who have studied straight line in mathematics, they know. Okay, this is represented by the symbol m. M is equals to tan theta. Now what is the slope? So tan theta, if you take this triangle, this is a right angle triangle. Okay, so tan theta is basically this height divided by this height. Okay, perpendicular by base. So this is perpendicular, this is base. Okay, so perpendicular, what is the height of the perpendicular? So if you see that this much height is v0, this much height is v. So this much height must be v minus v0. Okay, so this height is v minus v0. And what is this distance? This distance same as time t. So from here you can calculate the slope. So finding the slope is major thing when you are solving from graph. Okay, once you have done with the slope, remaining equations are very easy and simple. You can find it. Okay, so let's start now. So here, as you we have drawn the graph. Now if you see that this is the height of the triangle and this is the base of the triangle. The base of the triangle is given by t, the height is given by v minus v0, and if this is the angle theta, the slope is tan theta, and that slope is actually in velocity time graph. Slope gives the acceleration. Slope equals to acceleration. In case of velocity time graph, slope is actually equals to acceleration. This much knowledge you have to know. So once you know this, that velocity time graph acceleration is given by the slope, you can write a equals to, what is slope? This divided by this. Okay, so this is v minus v0 divided by time t. Okay, so from here you can calculate at. Now based on question to question, we will simplify some different values. Okay, this is our starting point. So from here we say that velocity v equals to v plus at, v0 plus at, sorry. this v naught will come to this side and become positive. So v naught plus 80. This derivation we have done for 2 marker section. We have done this derivation. This is a simple easy derivation. Same question can be asked as a 2 marker simple derivation as well. So this derivation, this part is done. Next, what we have to find is we have to find x. X is the displacement. Now if you see in this particular graph, there is no sign of displacement. So how can we find displacement which is not given in this diagram? So for that, what you have to do, you have to know one more thing, that the area under the graph, area under the velocity time graph gives you the displacement. The area under the velocity time graph gives you the displacement. Area under the graph means you take this line, whatever inside this line is called area under the graph up to the axis t. Okay, so whatever area is there, for example here we have a rectangle and we have a triangle, so the total area is basically the displacement x. Okay, so x is the total displacement. So now let's try to find x. So x is the total displacement and that is the area under the graph. Right? X is the area under the graph. Now how to calculate the area under the graph? So here we have a rectangle. Okay, what is the area of this rectangle? So we can say that x equals to area of the rectangle ACDO plus triangle ABC. Okay, these two are independent. Obviously if we take this rectangle and add the triangle, we get the total area, right? What is the area of a rectangle? Area of a rectangle is base into height or length into breadth. Here length is t and breadth is v naught. So we just simply say v naught into t. Okay, v naught into t is the area of the rectangle. Now what is the area of the triangle? Area of the triangle is very simple. Half base into height. Okay, half base into height. Base is here time t and height is v minus v naught. Okay, this triangle only, so its height is v minus v naught. Okay, now from here v minus v naught is at from this equation. So this equation is obviously not required. I just showed you for reference. So at equals to v minus v naught. So we just need to put it over here. So very simple derivation, but very common, mostly asked question into at. So you get the derivation v naught t plus half at square. So this is the derivation, this is the proof that you are going to do. Now what you have to write over here, first of all you have to write slope of the velocity time graph gives the acceleration. We know that slope of the velocity time graph gives the acceleration. From there you have to calculate up to this point, mark it as equation 1. Secondly, you also have to mention that we also know that the area under velocity time graph gives the displacement. So from there we can say x equals to area under the graph, or x equals to you can name it any time. The naming does not matter. You don't have to remember ABCD or AOCD. What you can name it as much as you wish. Just origin you make it O. Okay, this is the origin point. Origin is generally marked with O, right? 0, 0. So mark origin as O, and any points you can mark A, B, C, D, whatever way you want. Okay, then you say that this is the rectangle, this is the triangle based on your diagram. Do not try to remember the values from here and write something else in the exam. Okay, and then you just have to put these values, and from equation 1 we can write v minus v naught equals to 80. So from equation 1 we just in bracket you write from equation 1. That's it. Very simple, very easy, but very common. Okay, so if you do the derivation you get the full marks. Next, another derivation that comes, derive the expression v square equals to v square plus 2x from vt graph. Again the same graph we are going to use, so I am not explaining the graph once more. So same graph you have to draw, same concept you have to use. So what is the first concept? First concept was slope. And what is slope? Slope is basically acceleration. So acceleration equals to v minus v naught divided by t. Okay, from here if you see that in this equation time is not there, in this equation time is not there, so we just have to find t equals to v minus v naught by t by a. Okay, so this is the only difference. So you need to know what you are doing, and based on that you have to adjust the derivation. Same derivation, one derivation, if you practice you can answer both derivations. Only thing you have to know where we have to change, because in the previous case if you see, okay, here no v involved, so we had to replace v. In this case no time involved, so we have to replace whatever equation we will get, we have to replace the time. And our formula is same. Okay, our formula again is same, that x equals to area of the rectangle AODC plus, this is the only thing that you can get from the graph. There are two things you get from a graph: slope and displacement. Slope is equals to acceleration and displacement equals to area. Okay, so these are the only two things you get from the graph, and you have to manipulate these equations, you have to simplify this equation based on your final result given being asked from you. That's it. Okay, so x equals to v naught t plus half into v minus v naught into t. Okay, now as we know that what we have to do, we have to replace the time t, but before doing that I will teach you how to simplify it faster. Multiply all term with 2, so you get 2x 2v naught t. We can do that, multiply both sides with 2. Okay, 2v naught. Now here we get 2 by 2 into v minus v naught into t. So obviously 2 by 2 cancels, we get 1. That is the major thing. Now what you have to do, you have to take t as common. So if you take t as common, you get 2v naught plus v minus v naught. Okay, so here you have 2v naught, here you have minus v naught. So here we got t into v plus v naught. Okay, v plus v naught. Now what you have to do, just one step remains, is that you have to substitute this t with the equation 1. Okay, so if you substitute that, you get 1 by a v minus v naught v plus v naught, and that is from equation 1. This is slightly longer than the previous one, but mathematically almost same. Now take this a on this side, we get 2ax. Obviously we had 2x common over here, right? So just multiply it, we get 2ax, and we get 1 upon a v square minus v naught square. Okay, a square minus b square formula, right? Sorry, one more mistake I made. This should not be 1 by a. 1 by a is already taken care of. Now just simplify it, we get v square equals to v naught square plus 2ax. Okay, so this minus come to this side becomes positive, and then we have just inverted it. Okay, so this is the derivation for this one. Slightly longer, more common than the previous one, but this is also the last one also very important. This one is also very important. Both derivation, if you practice it 2 times, you can solve both derivation in the exam hall. Okay, now next, state the law of conservation of momentum. Prove laws of conservation of linear momentum using Newton's law of motion. Another very common, very interesting, important question. So first of all, you have to mention the law. You have to mention the law, and it is compulsory. If you don't mention it, 1 mark will be deducted. The total linear momentum of an isolated system remains constant if no external force acts on it. Very simple. So here we have 2 objects, A and B. Okay, suppose initially they are moving towards each other, so that part is clear. So these 2 objects are moving towards each other initially. Say the mass of A is ma, mass of B is mb. Okay, so initially they are moving with the initial velocity, say ua, and this one is moving towards it with a velocity say ub. Now as you see, we are not using v0. That might complicate it because obviously we have to write a lot of variables. So ub, ua and ub are the initial speeds. Now after they come closer, they collide with each other, and after the collision, immediately after the collision, okay, does not matter elastic collision or non-inelastic collision, after the collision what happens, this object exerts a force on this and this object exerts a force on this. Okay, so this force say F on B due to A, and this force say F on A due to B. Okay, so this is A, this is B. Now after collision what happens, A moves with the velocity v A and B moves with the velocity v B. Okay, mass is obviously same. So this diagram you have to draw compulsorily, okay, to explain it. Now what we can say about these two forces? First of all, so we can say from Newton's law, third law of motion, these two forces must be equal and opposite. So we say that F AB must be equals to minus FBA. Now what else? From second law, so first law tells that the force must be, third law tells that the force must be equal and opposite, and second law tells us that force is actually equals to rate of change of momentum. So mv minus mu divided by time t. Suppose the time of collision is small t, time during which they are in contact. Okay, so the time of collision say small t, so we can say that that must be equals to the momentum change of object A, and that should be equals to change in momentum of object B as well. Now how to find the momentum? So this is the formula. Okay, so because both objects have same mass, so mass can be taken common and you can say v minus u. Okay, but we are not doing that. We will write the total form. So what is the total momentum of object A? Momentum, initial final momentum is ma va. Final minus initial. Always remember final minus initial. Initial momentum ma ua, and time of collision small t. Does not matter, it will cancel, and that is equals to minus final momentum of B mb vb minus initial momentum of B mb ub, okay, divided by t. Both have same time. So from second law we are getting this. So this is from third law, this is from second law. Okay, you have to write the second law form and then you have to come back to this form. Okay, now time t gets cancelled. Now whatever is left is the rearrangement. So ma va minus ma ua equals to minus, there is a minus sign, right? From Newton's third law, they are opposite in direction, so that's why minus sign is there, plus mb ub. Equal and opposite force, right? From third law we know that if object exerts a force on another object, the object gives equal and opposite reaction. So equal and opposite means negative sign. Equal means obviously the equal sign, and opposite means this negative sign. Now whatever is left is to rearrange it. So mb vb, everything related to v should go on one side, va plus mb vb, and this goes to the other side, becomes ma ua, and this is already plus mb ub. Now what is this? ma va plus mb vb. So this is the final momentum of A, this is final momentum of B. So that means if you add these two, you get final momentum of the system, and this is the initial momentum. Now here Remember, the conservation of momentum principle is only valid when no external force is acting on the system. Okay, so total linear momentum is constant if no external force acts on a system. So here, as you can see, only internal forces are there between two objects, so no external force acts on them. So in that case, their total momentum has to be conserved. It does not matter what type of collision it is a elastic collision or non-elastic collision, it is immaterial to that. So momentum will always be conserved. Practice this easy derivation, again very common, asked across different colleges. Now next, before going into any further, I just want to remind you that if you want to download the PDF of today's session and all the sessions that we have done, you have to join our WhatsApp channel. The link of the WhatsApp channel is given in the description section of this video. So from there you can join our WhatsApp channel and get the PDF. Okay, so the link will be provided from in the description. Click on read more and you will get the second link as your WhatsApp channel link. So once you click on that WhatsApp channel link, you will be redirected to our WhatsApp channel. If you are watching it from our mobile phone and the mobile phone has WhatsApp, then you have to, what you have to do, you have to follow it. Okay, if you are using it from a web browser, then you have to open the same link in your mobile phone and go to the WhatsApp channel and click on the follow. Or if you have a web browser of your WhatsApp on your web browser opened, then you can follow from web browser of WhatsApp as well. Okay, so don't forget to join the WhatsApp channel. I want to see everyone who is watching this video till now have joined our WhatsApp channel. Now next, show that the trajectory of projectile motion is a parabola. Very common, most important derivation of all. Okay, this is the most important derivations of all, and across colleges, across district, this is one of the most favorite question by teacher. Okay, so what you have to do, first of all, what is the meaning of trajectory? Trajectory means, suppose this is a first of all, let us understand the projectile motion. So here we have two axes, one is along this direction, one is along height. Okay, this is the height direction, this is the horizontal direction. Okay, now so when you so this is our x-axis, this is our y-axis. Both are positions. Okay, both are distances. There is no time here. There is no time here in this graph. The diagram that I am going to draw is not involving any time. Both are directions. This is x direction, this is y direction. Okay, so those who have done conic section chapter in your mathematics, some concepts are there, circle, straight line. So basically coordinate means, what is the meaning of this? Ax plus bx equals to c. What is this? This is a straight line, right? So if I give you an equation like this, giving some values of a and b, of course, you can immediately say, sir, this is a straight line. This is the equation of a straight line. Similarly, there are other conic sections. One of them is parabola. Okay, one of them is parabola. Generally, the parabola equation that we study is y square equals to 4ax. This is one of the easiest form of parabola. Okay, generally if one of the term is square, other coordinate is in single digit, then that is considered to be a parabola. General equation, I mean, suppose y square, you find something, y square equals to say ax plus b. This is a general equation of parabola. It can be written like that. X square equals to say ay plus b. This is also a parabola. Okay, one parabola can be first parabola is like this, another parabola is like this. There are two types of parabola. Okay, this parabola starts from origin, this parabola does not start from origin. That is the basic difference. Okay, now so we will find the equation of the trajectory. That is very essential. Okay, not the height or not the range. Okay, so height and range are not important over here. We will do one more derivation where we do the height and range, but in this case height and range are not required, and it is very easy derivation. So when, first of all, the diagram is compulsory in this derivation as well. So here what you have to show, that first, suppose you have projected a projectile in a velocity, say v. We are taking v, not u but v. Okay, this angle say theta. Okay, and based on your velocity, the projectile will travel like this, some motion. Okay, and you have to find what this graph represent? Is it a circle? Is it a straight line? Obviously it's not a straight line. It has to be like a circle or ellipse or a part of a parabola. So that's what you have to show here. Okay, now how to do that? Very important. So we have to take a random position, a random point on this line x comma y. We have to take a random point on this line x comma y, and if we can find the relationship between x and y, then we will say that this is the equation of a parabola. So you have to relate x and y. They are not independent, obviously. So you have to find the relationship between x and y. Now this angle is theta. That means the x component of motion is given by v cos theta. This is adjacent angle, adjacent side. So for adjacent side it becomes cos theta, and for perpendicular it becomes sin theta. Okay, one is v cos theta, another one is v sin theta, right? We all know that in vector resolution we have done it. So if there is a vector, and if we know what is the if we know the projection, we can find the x and y components, right? So this is v cos theta, adjacent sides are cos theta component, and perpendicular component is sin theta component, right? So now, so sin theta cos theta is figured out. Now what? Now what we have to do? We have to relate them. Let us say that this particle is moving along this, right? So the whatever particle is taking, so say after time t second, it reaches at this point. So whatever time t is taken, x coordinate also, y coordinate also, both takes the same time. Now what is the meaning of x comma y? Obviously from x axis the distance is x, and from y axis the distance is y. From x axis the distance is x, from y axis the distance is y. Now in y axis we do not only have this v sin theta component, we also have a negative gravitational acceleration which is acting downward direction, right? Gravitational acceleration is always acting on an object and it is trying to pull the object back. So there is a negative gravitational acceleration in this direction, but in the horizontal direction only v cos theta is there, no other component of velocity or acceleration is there. Okay, only v cos theta is driving it along the x axis. So we can say that, so x, so what is x? Obviously this distance is x, this distance is x, and this distance is y, right? Now what is this x? Time given is t, velocity given is v cos theta. So x is the displacement along x axis, so we can say that x equals to v cos theta into t, right? V cos theta into t. Here t is a parameter, time is a parameter over here. So if t is a parameter, what we have to do? We have to replace t and we have to find t in terms of this. This is step number 1. Next we have to find y now. We have to find y now. What is y? Y is the velocity, that is v sin theta into time t minus half gt square, x equals to ut plus half at square. So same formula we are using here as well, only difference is because it is in the opposite direction of the velocity, there is a negative sign, and velocity itself is v sin theta. Okay, so v sin theta is the component and t is the time on which it is moving along y axis, right? So this is the displacement along y axis. Now only one step remains. Take this t and put it in this equation. So only one step, that is v sin theta into x divided by v cos theta. V cancels, and here we get minus half g into x by v cos theta whole square. Okay, now just simplify, we get sin by cos, that is tan theta into x minus half g divided by v square cos square theta into x square. Okay, or we can say that this is equals to ax plus b x square. So y equals to ax plus bx square. So this is an equation of parabola. Now remember you have to mention what is a, what is b. So here a is equals to tan theta and b equals to minus half g divided by v square cos square theta. Okay, so this is the b, this is a. Now if you have reached at this position, you can easily say this is a parabola. This equation is a equation of parabola. Okay, so once you know that, your derivation is complete and 5 marks is secured. Okay, not very difficult derivation, but if you don't practice it, you might get forget. So you have to practice the derivation once, at least once or twice. Okay, easy derivation, conceptually very easy. Only thing you have to remember that you have to find x and y. How to do that? Just use the equation of motion. For x-axis only x component is there, so v cos theta into t. From there you have to find t. Second is y direction displacement. In y direction we also have acceleration, so we have to use s equal to ut plus half at square. Only thing that because gravitational acceleration and velocity are in the opposite direction, you have to take gravitational acceleration as negative. That's it. Then just put the value of t and simplify. You will be able to solve it. Okay, now next, find the maximum height and range of a projectile. Again we are doing the projectile part. Now this can be little tricky. Now here we are trying to find the maximum height, this height h, and the range which is given by r. Okay, so this is also same. The part is also same, the v part. Okay, so velocity is along this direction, say v, and the angle given by theta, this is v sin theta and this is v cos theta. Okay, this is v cos theta. So v sin theta, v cos theta should be same as previous part. Okay, now what? Now only thing that only difference is that in the previous case we have taken an arbitrary time. In this case we cannot do that. We have to take the time. So time to reach the maximum height, that time we will say is small t. Time to reach maximum height, time to reach maximum height, say t. Okay, this t we will find, and total time of flight also you have to find. Total time of flight is what? Total time of flight is capital T equals to 2 into t. Okay, now why we have separated the motion into two components? First of all, if you study projectile motion, why we have to separate the motion into two components? Because they are independent of each other. The vertical component is independent from horizontal component. They are not dependent on each other. Horizontal component is fixed, whereas vertical component depends on gravitational acceleration, which is acting in the downward direction. Okay, and if you see that, suppose you have just thrown an object like this, so the object stops at the top position, then it falls back, right? So if you ignore the horizontal motion, basically what is happening in projectile motion, it is going up and falling back. Okay, it is just simply going up and falling back. So that time is the total time, capital T, and we know that time to take the time taken to reach that maximum position is equals to time taken from maximum to ground. Okay, both are same, and at the maximum position what happens? The velocity becomes 0. So at height capital H, the instantaneous velocity becomes 0. So v equals to v sin theta. So this is v dash. Okay, don't be confused. V sin theta into small t, that is the time t we have taken, minus half gt square. This is the formula. Sorry, what I am doing. V sin theta minus gt, u minus at. Okay, u plus at, here gravitational acceleration is negative, so that's why minus gt. Okay, v equals to u plus at, right? This formula we are using. So here v is v dash, u is v sin theta, and instead of 8 we are using minus g, time is t. So from this equation, what we will say, at maximum position V dash is 0. So 0 equals to V sine theta minus gt. So T equals to V sine theta by G. So this is the time to reach the maximum height that we have calculated, and total time is 2t, and that is 2V sine theta by G. So these two parts you have to do first. Now once you have done these two parts, remaining part is very simple. For maximum height we will use the equation for height, that is H equals to ut minus half at square. Here minus means gravitational acceleration, so generally plus, okay, because G is minus, so we will use that equation. So what is u over here? U is V sine theta. U is V sine theta, and time taken to reach maximum height is t minus half g t square. Okay, so this equation, very simple, easy equation. Now only thing that is there, you have to put this value of t in these equations. Both cases you have to put this value. So V sine theta into V sine theta upon g. We have to put the small t value, okay, minus half g into V sine theta by g whole square. So if you simplify, you get V square sine square theta divided by g minus half V square sine square theta divided by g. So one of the g will be cancelled, g square is coming over here, so one of the g will be cancelled, and you will get this equation. So if you take V square sine square theta by g as common, you get 1 minus half, so that is half V square sine square theta by g, or H equals to V square sine square theta divided by 2g. Very easy, simple. So maximum height is calculated. Now range also you have to calculate. Okay, range also you have to calculate. What is range? Again, in x-axis there is no distraction, so only motion is happening along the x-axis. Now in this case you have to use the total time t, because the maximum height is reached over here. Then again it is falling for another small t time t. So up to reaching up to this height is small t, again small t, so total time is taken is 2t. So here, or capital T, the time period of the motion. So R equals to V cos theta into capital T, or 2t. So just put the value V cos theta into 2V sin theta upon G. Okay, so that means V square 2 sin theta cos theta divided by G. Okay, so we have just multiplied V into V square, and 2 into sin theta 2 sin theta, and there is a cos theta, just multiply. Everything is multiplied, right? So we can write V square sin 2 theta upon G. This is the range of the projectile. So range part is easy. Okay, whereas height part is slightly tricky, slightly longer, but combining both of them is not very difficult. If you practice again 2-3 times, this can be very easy derivation. Derive the expression for acceleration due to gravity at a point below the surface of the earth. So in the gravitation chapter there are 3 main derivation. Okay, one I will be doing, 2 I will be doing in this lecture, one more I will be doing in another separate lecture. Okay, so please wait for that as well. 2 derivations I will be doing in this lecture, and these 2 are the most common and mostly asked. Gravitational acceleration inside the earth, gravitational acceleration at a height. So these 2 are the most common. Now inside the earth is slightly tricky, even though derivation wise mathematically they are easy, but students forget that how to do the derivation. So first of all, you have to understand that this is earth, and when you go a deep, say a depth of d, when you go below a depth d, okay, then what you have to consider is that only the mass inside this sphere is what is relevant. Any mass outside the sphere, all the height depth d from all sides, you are measuring here. Okay, so, but all the height from all other sides are actually irrelevant. It's like a onion peel. Okay, so you are going into a inside part of an onion. Outside peels of onions are immaterial. They does not matter. So only what you have to do, you have to consider the mass of the inner sphere. Okay, you have to consider the mass of the inner sphere. Say the inner sphere of radius small r. This is the radius of the inner sphere. The outer sphere radius, we know that is the radius of the earth, that is given by capital R. Okay, now this derivation is only possible when we assume that earth is a uniform object. That means its density is uniform throughout. Suppose this is the mass density. Density means mass divided by volume. Okay, so same density should be for outer sphere as well as for inner sphere. And we have to find the individual masses. The total mass of earth, say capital M, okay, which is known value. The inner mass, which we do not know, say M dash. And the inner mass of the inside part, say M dash at a depth D. Okay, so first of all, small r is actually equals to capital R minus D, right? This much clear. Total radius is capital R. So if you take this much out, then you get smaller. So this much is what? This much is the depth at which you are measuring, which is given by D, small d. So small r is actually capital R minus small d. So this is clear. Now what? Now we have to find the mass of the earth in both cases. So when the earth is, you are measuring the total mass of the earth. How to find the mass? If you know the density. Mass is given by volume. Mass is given by volume into density. Okay, mass is given by volume into density. So what is the volume of earth? Earth is a spherical object. So what is the volume of a sphere? Volume of a sphere is 4/3 pi r cube into rho. This is the total mass of the earth. This is the total mass of the earth. But we are not interested in this mass anymore. We are more interested in the inner mass. So what is the inner mass? So in the same way, what we can say that the inner mass is 4/3 pi. Now radius is no longer capital R. Radius is this. So r minus d whole cube rho. So we have found the these two masses. And one more thing that we have to do, you have to find the ratio of capital M by small m for our own purposes. So capital M by small m will be given by, see, everything will be cancelled except these two r's. 4/3 pi, 4/3 pi, rho will cancel, only you will get r minus d whole cube by r cube. We will use it at a later stage. Keep it over here. So mark it as equation number 1. Okay. Now, what is the acceleration due to gravity on the surface of the earth? Acceleration due to gravity on the surface of the earth is gm upon r square. If you forget it, I have done this derivation in 2-3 marker. You don't need to do this derivation. Okay, if you forget the derivation, you just remember that weight of the object is given by gravitational force. So weight must be equals to gravitational force. Weight must be equals to gravitational force. Gravitational force is gmm by r square. Okay, so from there you can calculate the gravitational acceleration, which is given by g equals to gm by r square. Right, now what? Now you have to find the gravitational acceleration at a height, at a depth d. So gravitational acceleration at a depth d is given by g m dash by r minus d square. From the same way we can write the gravitational acceleration at a depth g. So that's why I have found this ratio. Okay, so this ratio is going to be very, very handy. Now g dash by g can be written as g m dash by r minus d whole square into r square divided by gm. It is division, so this gets flipped. Okay, so g gets cancelled and we get m by m dash into r square by r minus d whole square. Okay, now we just need to put this value in this equation and simplify. So it will be r minus d whole cube divided by r cube into r square divided by r minus d whole square. So r minus d whole square cancels, only 1 is left. Again r square and r cube cancels, and we get this as r minus d divided by r. So it gets 1 minus d by r. Okay, so we get the ratio of g equals to g minus equals to 1 by r minus r. So from here we can say g dash equals to 1 minus d upon r into g. Okay, so this is the gravitational acceleration inside a point on Earth. Okay, now let's move on to question number 7. Derive the expression for acceleration due to gravity at a point above the surface of the Earth. Okay, this can be also tricky, but the last one is slightly more trickier, because you have to take the different masses. Here mass of the Earth is same. Okay, only thing is the height is changing. So initially the object was supposed on the surface of the Earth, and gravitational acceleration on the surface of the Earth is given by the formula gm by r square. Okay, now if you take the same object, say at a height h from the surface, if you take the same object at a height h from the surface, then what is the distance from the center? Distance from the center will be r plus h, right? So gravitational acceleration will be gm by r plus h whole square. Okay, gm by r plus h whole square. Very simple. Now what? Just find the ratio. Again, g dash by g, and we get gm gets cancelled, because earth when you are outside you have to consider the total mass. Okay, there is nothing in here, so those extra mass you do not need to consider. So only mass you need to consider is the total mass of Earth. So just find the ratio. So you will get r square divided by r plus h whole square. Okay, here we have to do a little bit of more steps. So 1 by r plus h whole square divided by r square. So what we have done, we have taken this r square in the division. Okay, so this can be little tricky, or this is 1 plus h by r whole square. So we have taken this r square inside it, and we have done what we have done. We have done r plus h by r whole square, right? We can write this number like this, square in both sides, so square is common now. And then what we have done, we have done r by r plus h by r. R by r is 1 and h by r is h by r. Okay, or we can say this is equals to 1 plus h by r. Sir, you are writing it wrong, it was in the division. Yes, so that's why we are doing it to the power of minus 2. Okay, so this is g dash by g, so g dash equals to 1 plus h by r to the power minus 2 into g. Now sometime they will ask you also show the gravitational acceleration for a small height, if the height is very small. Okay, for example, you are traveling in a plane, so that height can be very small compared to radius of the Earth. So if h is small, very small compared to radius of the Earth, suppose it is a height of say 32,000 feet. 32,000 feet means you can calculate. So radius of Earth is 6400 kilometer. Okay, so that compared to that, the stratosphere height is around 10 kilometer to 15 kilometer. So that is very reasonable. You can still use this formula to calculate the gravitational acceleration. So g dash equals, this can be expanded binomially. Okay, binomial expansion, and this can be taken only up to minus 2h by r into g. This is not a general formula, this is a special formula only when h is very less than r. Okay, so they might also add one part here, if the point is near to the surface of the Earth. Okay, so if they say that at a point on the surface of the Earth, this is the common derivation. If they say near to the surface of the Earth, then definitely you have to show this derivation. Okay, up to this you have to reach up to this formula. Okay, so what happens is that this minus 2 gets multiplied with this second number. Okay, minus 2 gets multiplied with the second number, so minus plus and minus becomes minus, and 2 is multiplied, so 2h. That's what is happening, and there are multiple terms in there, but because we are taking this special approximation, in that case the other terms will be very close, very small, and will be 0. This is an example of binomial expansion. The expansion series may not be in your syllabus, but you should remember this small application. Okay, now let's move on to the next derivation. Using first law of thermodynamics, arrive at the relation Cp minus Cv equals to R. Another very important and most asked derivation. What is first law of thermodynamics? First law of thermodynamics says if we have a system, if we give it a heat of dq, okay, and we are going to do the derivation in differential form, not the delta form. Okay, delta forms is confusing, and because many of you already have done differentiation, basic differentiation in your mathematics class, so I will be using differential form only. So if you supply a system with the heat dq, then part of this heat is basically utilized in doing work, and remaining also being utilized to increase its internal energy. So suppose you are giving some energy to someone, what they will do, they will take some money for themselves, and remaining part they will perform the work. Okay, it happens everywhere, right? So dq is equal to dw plus du is the first law of thermodynamics. Now in first law of thermodynamics there are two processes, Cp and Cv. Now if you try to find the work done is generally given by P into dV. For any system, work done is given by P into dV. So from first law we say that dq equals to du plus P dV. This is the general form. Okay, now in physics it is very simple. You give dq amount of heat, part is given to work, part is being done as work, and the remaining is basically the internal energy change, right? So and that work done is given by P dV. Now what? Now we have to take consideration of two cases, Cp and Cv. So what is Cp? Cp is very simple. Pressure is constant. Okay, specific heat at constant pressure. So it is basically the amount of heat you supply and corresponding increase in temperature at a constant pressure. So this ratio is called Cp. Definition of Cp is the heat you supply and corresponding change in temperature at constant pressure is called Cp. Now, so basically it's a differentiation. Okay, so you can say that this is nothing but du dt at constant pressure plus ddt of, or not ddt, say P is constant, right? P is constant means this P is constant, so P will come out dV dt at constant pressure. Okay, P is constant, so P will be out of the differentiation anyway, and you will get dV dt, right? Now what? Now du does not depend on pressure. Du depends only on temperature. So du dt at constant P does not make any sense. So you can simply write this as du by dt without any constant. Du dt at constant pressure and du dt at constant volume should be same. Only if temperature is constant, du will be 0. Okay, du depends only on temperature. So du dt at constant pressure does not make any sense. We have to find this value dV dt at constant P. So for that, what we will be using? We will be using our ideal gas equation, which is Pv is equal to RT for 1 mole gas. Okay, for 1 mole of gas. Okay, now so what we will be doing? We will be differentiating both sides with respect to time temperature T. P is constant, so differentiation means constant will be out of the differentiation. Okay, so if we differentiate, say a into x, if I differentiate with ddx, then obviously a is constant, so it does not get differentiated. So P is constant, it comes out of the differentiation, and we get dV by dt. And obviously because we are doing it for constant P, P generally is not constant, but for Cp, for calculating Cp, we take P as constant. Okay, that's why P is being treated as constant here. and that is equals to R ddt of dt. Okay, so this R is obviously universal gas constant, so only T will be differentiated. ddt of dt is equals to 1, so we get this equals to R. Okay, so we get P dV dt is equal to R. So just put that value over here. Okay, so Cp we have calculated. Now we have to, it's time for us to calculate Cv. Now for Cv, volume constant, that means dV equals to 0. Volume constant means change in volume is 0. So for Cv, in the term PV, what we can say is that Cv equals to, definition is same, dq by dt at constant volume V. Only thing changes is constant volume V. So at constant volume V, dV is 0. So PdV term is completely gone. So we can write this as du by dt at constant V. So we are taking this value of dq from this equation, but we are taking dV as 0, constant volume, dV 0, work done is 0. So in that case, only du dt is left. Now as I mentioned, du does not depend on constant volume or constant pressure. It only depends on temperature. So we can simply write Cv equals to du by dt. Okay. Now obviously what we are trying to find, we are trying to find Cp minus Cv, that is du dt plus R minus du dt. Okay, du dt cancels, and we get Cp minus Cv equals to R. Now remember, in this derivation, if you are doing the differential method, even though it's much easier, only thing you have to remember that you have to take this step. Okay, so du dt is dependent only on temperature. That line has to be mentioned. Okay, then only you can take du dt at constant P to be du dt. Okay, some students keep on this P and V and they cancel it later stage. That is also incorrect. So you have to make sure that this is neutral, du dt is neutral, then only you can cancel it. Right? Now next derivation, derive an expression for work done by the gas in isothermal process. Isothermal is a very slow process. Okay, and work done obviously is given by dW equals to, thermodynamic work done is given by P dV. Isothermal means temperature constant. Isothermal is constant temperature. Okay, isobaric constant pressure, isochoric constant volume. Okay, these are the three processes, right? Isothermal and adiabatic. Adiabatic process means everything changes randomly. Okay, so dW is equal to PdV is the thermodynamic work done. You don't need to prove this derivation, how dW is equals to PdV. Anyway, so you have to find the isothermal work done. Okay, and to find the total work, what you have to do, you have to integrate this dW, or you have to integrate this P dV. Now remember, here P is not constant, because work done, isothermal work done means it is not at constant pressure. So pressure is not constant for isothermal process. When I was a student, no teacher told me that pressure is constant. Okay, I was struggling why in the previous case when we are doing Cp by Cv, we are taking P constant. In adiabatic, in isothermal process, when why we are not taking P as constant. So that was a very big trouble for me, because I was studying for the first time and it was very difficult for me, at least at your stage, at your age group stage. Later on I figured it out myself, and then I saw, oh, that's why it is P is constant in the previous case, and in this case P is not constant. So if you are someone who is struggling with why we cannot take P out of the integration, then you are basically don't worry, it happened to everyone. Now integration may not have done in your class, but we will use basic integration where it is just basically a something that you have to remember. That's it, one or two formula that you have to remember. Nothing, no rocket science over here. So what you have to do, first of all, you have to, whenever you are differentiating or integrating, the variables and the differential should be of the same thing. So here one quantity is given P, but we are integrating with respect to V. So that is not allowed. So what you have to do, you have to replace P with something which is similar to that of V. So for that we will go back to our equation PV equals to mu RT. I am taking mu in this case. Okay, I am not taking 1 mole gas. It is valid for any number of mole gas. Previous case also, if they say Cp minus Cv is equal to mu RT, then you have to take mu mole of gas. Okay, because it was given Cp minus Cv equals to R, we have taken for 1 mole gas. Okay, that's it. So P is basically mu RT by V. Obviously, temperature being constant. Now we have to put this value of P over here. So we get integration mu RT by V dV. So now if you see that our variable is in terms of V, and also differential is also in terms of V. Mu is constant, R is constant, T is constant, so they come out of integration. Similar to that of differentiation, if it is a constant, it comes out of the integration as well. Now this derivation you have to remember. Now you are trying to find total work done, so we have to, and we are differentiating with respect to V. So initial volume to final volume. Now remember, volume when we are writing, we write capital V. Velocity when we write small v. Well, that is a small difference. So from here we can say, now this integration may be something new to you, but you have to remember this integration is basically ln of V. V initial to V final. This is called lower limit, this is called upper limit. Okay. Now this is equals to mu RT. First we have to put the upper limit. So ln, what is ln? I am explaining that as well. So ln Vi, ln or ln, whatever you say. So ln is basically a log but with base e. Okay, generally log is with base 10. Okay, but ln is a very specific symbol which is basically used for log to the base e. Okay, so it is nothing different than log, but it comes so many times in physics that using log base e is very difficult. So that's why we use ln. Simple symbol represents, it's shortens the writing. Okay, we have to writing 4 letter over here, here only 2 letters. So that's why to shorten the duration, this is very much used in physics. Now what we know that log A minus log B to some base, okay, it can be written as log A by B. Okay, log A by B. So from here we can say that this is equals to mu RT ln Vf by Vi. Okay, this is the work done in isothermal process. Now last derivation, derive, don't go anywhere, we also have the numerical questions. Okay, derive the expression for the kinetic energy and potential energy and total energy of a simple harmonic oscillator. So simple harmonic oscillator means obviously its equation is given by x equals to a sine omega t plus phi. You can ignore the phi or you can take the phi. Okay, x is the displacement of simple harmonic oscillator and that is given by a sine omega t. Now what is kinetic energy? Kinetic energy is simplest. Kinetic energy is half m v square. So if we can find velocity, we can find the kinetic energy. How can we find velocity? Velocity is given by rate of change of displacement. So we need to differentiate this with respect to time once. So just differentiate it, we get a. I hope you are doing differentiation practice. So omega is constant, it will come out, and we get sine will become cos omega t plus phi. Okay, so just put those values over here. Half m is the mass of the, you have to declare the variables by the way. Okay, a omega cos, let me adjust the space. So kinetic energy K is equal to half mv square. So half m into a omega cos omega t plus phi whole square. So we get half m a square omega square cos square omega t plus phi. Okay, so this is the kinetic energy. Simple. You don't have to do anything else. Next is potential energy. Now potential energy is slightly tricky. Potential energy is given by half force into displacement. This one you have to remember. Okay, how this comes, for that you have to do some integration and some backward calculation, but you have to remember the potential energy is given by half F into X. What is F? Force is given by half m into A into X, right? A is acceleration. You can find A from one more formula from over here. Now here we are obviously taking the magnitude. Okay, negative sign, generally acceleration comes to be negative. Okay, so acceleration is A omega square sine omega t plus phi, and there is a negative sign is here. Okay, same, differentiate this once more, you get this acceleration. Okay, you can remember it as well. So half, negative sign we are ignoring, A omega square sine omega t plus phi into, what is X? X is A sine omega t plus phi. Okay, so you get half A square omega square sine square omega t plus phi. Okay, so this is the potential energy. Okay, m is also there. Okay, so this is the kinetic energy, this is the potential energy, and total energy is basically kinetic plus potential. So obviously you can see half m A square omega square is common, and you get sine square omega t plus phi plus cos square omega t plus phi, obviously sine square theta plus cos square theta, so that becomes 1, and you get this is equals to half m A square omega square. Okay, so this is the total energy. Total energy of a simple harmonic oscillator is constant. Okay, so kinetic energy expression, potential energy expression, and their addition, we have done it. Now let's move on to the numerical section. So in the numerical section, I suggest you have to solve numericals at least from these 4 chapters. Okay, if you can do more than that, that is very good, but you have to practice motion in a straight line, motion in a plane, then Newton's laws of motion and gravitation. These are the important chapters from where you should practice numericals. Other than that, thermodynamics is another important chapter. From oscillations or wave, there will be one numerical, so you should practice if you get time. But if you practice numericals from these 4 chapters, at least 2 numericals you will be able to solve. Okay, that is guaranteed, but otherwise if you can solve more. Okay, and if your college suggests some other chapter, also you should practice from there, but in my opinion, in general, if you practice from these 4 chapters, you should be able to score 2 numericals. Right, now let's don't suggest from there only I will practice from only 2 chapters or 1 chapter I will get at least 1 common. No, not like that. You have to practice all 4 to get at least 2 of them. So we will be solving some extra questions as well. Let's see. A body let fall from top of a tower covers 45 meter in the last second of its fall. Find the height of the tower. Very interesting, important numerical. So let us understand the question first. So whenever you see a numerical, try to draw a small diagram to understand the problem. So we are allowing a ball or a body basically to fall from a tall building. So you are staying on a, say, a very multi-story building, or you visited your friend who stays in a multi-story building. You went to the balcony of your friend and drop a ball. Okay, don't do that. It can harm whoever is standing below. But imagine, okay, you imagine that. Okay, don't do it in physical cases, but imagine that you have thrown a ball from a tall building. Okay, so when and it is basically happening from the roof, so we are taking the entire height of the building. So entire height of the building, say, equals to h. Okay, now if you allow a ball to fall, that means initially it is at rest, so initial velocity is 0. Then why it is falling? It is falling because of gravitational acceleration. It is falling because of gravitational acceleration, and that is given by g, and g is 10 meter per second square. It is given in the question. Generally, if it is not mentioned, we will take g is equal to 10 meter per second square only. Okay, unless and until it is mentioned in the question 9.8, you should take 9.8. Otherwise, take g is equal to 10 meter per second. You have to mention that in the answer. Anyway, so g is equal to 10 meter per second, and you are allowing the ball to fall from the top. Now what happens? So when the ball reaches the ground, suppose the time taken by the ball to reach at the bottom, that is just touching the ground, is given by t. Okay, small t. So if the ball takes t seconds time to reach the ground, then we can say that from our equations of motion, what is the distance traveled by the ball? Distance traveled by the ball is exactly equals to the height of the building, which is h, and gravitational acceleration is g, u is 0, so we can say that h equals to 0 plus half gt square. Now here it is plus because the object is falling downward only, so the motion is happening in the same direction as the acceleration of gravity, right? So that's why it is positive. Some students get confused between in projectile motion, why do we take g negative, but in normal cases we take g positive. You have to understand the direction of motion. So in projectile motion, ball goes up, gravitational acceleration acting downward. In this particular case, ball is also moving downward and gravitational acceleration is also downward. That's why it is positive. Okay, now so this is the first equation, h is equal to half gt square. Now if we can somehow find this t, then our problem is solved. We can find the height of the tower. Okay, now but t is unknown. What is given is that the distance traveled in the last second, is 45 meters. Suppose the ball was here at t minus 1 second. The ball was here at t minus 1 second, and in the last second it traveled a distance of what? 45 meter. Okay, this is t minus 1, this is t. So last second means t minus 1 to t. Okay, so this is the 45 meter distance that is traveled in the last second. So how much distance it has covered? H minus 45. Okay, so how much distance it has covered? H minus 45, but distance we will not take. What we will take is the what is the velocity of the ball at this point? What is the velocity of the ball at this point? So that velocity, if we can calculate, we can find the distance traveled in the last second as well. Okay, so here what is the, or what you can do, one more thing you can do, you can find the height that is traveled in t minus 1 second, and then what is the distance traveled in t second, subtract them, that is also fine, but I will teach you a shortcut method, mathematically not that heavy, easier. Okay, what is the velocity at this point? If you can find this velocity, you can start with this velocity and 1 second of time, and you can say the displacement is 45 meters. So how to do that? So what is velocity? Velocity is basically given by only one thing, u plus at. Okay, velocity is given by u plus at, the simple equation we are going to use. So what is v? We are trying to find v, obviously. What is u? U was 0 when it started at the top. What is a? A is given by g. And what is t over here? T is not t, t is t minus 1, because the ball traveled from here to here, the ball takes t minus 1 second. Okay, so this is the velocity. So velocity equals to g into t minus 1. Okay, now what? Now we have to find the displacement of the ball from here to here. Okay, so we will write again h dash, this height say h dash. Okay, h dash equals to vt, v into 1, sorry. What is the time taken, by the way? Time taken to reach from here to here, 1 second only. So v into 1 plus, what is the acceleration? Acceleration is still g, right? still the acceleration is g. So we are using the same equation, but with the twist that here the distance is known and time is also known. Time is 1 second. Okay, so for 1 second we can use this equation. So h is 45 equals to v is g into t minus 1 plus half g. Okay, so everything is simplified. So mathematically this is not super difficult if you understand what you are doing. Okay, now you have to simplify. So 45 equals to 10 into t minus 1 plus half into 10. Half into 10 means 5. So 5 comes on this side. So we get 10 t minus 1 equals to 45 minus 5, that is 40. So 0 0 cancels, we get t minus 1 equals to 4. So t equals to 5 seconds. Okay, so t equals to 5 seconds. The total time of fall is 5 seconds. Now we just need to take this 5 seconds and put it in this equation. So half 10 into 5 square, that is 5 into 25, that is 125 meters. So the height of the tower is 125 meters. Okay, interesting problem. If you have difficulty understanding, try to solve on your own once. Okay, there are two methods to solve this. This is one of the method. I like it because mathematically you don't need to do a lot of complicated square related calculations. Okay, that's why I prefer this method. There is one more method, you can use that as well. Now, from the velocity time graph given below, calculate the total distance traveled. Now this is interesting question. Okay, they can give you the total distance travel, they can give you the average velocity, both is possible from a velocity time graph. Okay, so how to find the first of all we will calculate the total distance travel, then we will also calculate the average velocity. So if you see that this is a triangle. Okay, the graph I have chosen is simple. It can be slightly complicated than this as well, but you have to understand that the distance traveled is basically area under the graph. If you can calculate the area of this triangle, you can find the distance traveled. So what is the distance traveled? Distance traveled is given by S equals to area of triangle. Say this triangle, we name the triangle, say A, B, C. Now this diagram you have to redraw on your answer sheet. Don't make a mistake, you have to redraw the diagram in answer sheet and then you have to solve it. Okay, area of the triangle ABC. Now what is the area of a triangle? Area of a triangle half into base. Base is this, that is B into C, B to C, and height. Height say is here is D. Okay, so height is AD. Don't take two different triangles. Don't take two different triangles of this one and this one. No need. Both of them have same height. Both of them have the base should be single if you take the entire triangle as a whole. Okay, if you take the entire triangle as a whole, this becomes your height, this becomes your base. So you don't need to worry too much. Okay, so that is equals to half into BC is what? BC is 0 to 10, that is 10. And what is AD? AD is given here 12. Okay, so 12. So 12 is 60 meter is the distance traveled. Now what is the average velocity? So if they say that find also average velocity, so average velocity, okay, this is an additional part. So average velocity is total distance traveled by total time. Total distance traveled by total time. So if they ask, if they give you the graph and they ask you what is the average velocity, then also you have to calculate the area first. Okay, so area has to be calculated. Now average velocity is total displacement divided by total time, that is 60 divided by 10 seconds, so that is 6 meter per second. So average velocity is 6 meter per second. Okay, even though the velocity is changing from 0 to 12, 12 to 0, okay, but average velocity is 6 meter per second. Correct answer is 60 meter. Average velocity I am giving you as an extra part because in the this question requires little less calculation. They might add average velocity to it and then they will give you as a 5-mark question. Now a ball a ball thrown vertically upwards reaches the balcony of a house 100-meter high. At the same time, another ball B is dropped from the rest from the balcony of the house. When and where will the two balls passes to each other? So here we do not have a tower, it's a height building, and we have a balcony. Okay, from the balcony, what you are doing, you are standing over here. Okay, you thrown a ball, and at the same time your friend is standing on the ground. Okay, he is throwing a ball in the upward direction. The height is, the difference is 100 meter, it is given. Now it says that both of the balls are being thrown at the same time. Okay, both balls are thrown at the same time and they meet somewhere. They meet somewhere after, say, time t. Time should be same, right? The ball that it takes to reach at this height and the ball that it takes goes up. So both ball takes the same time to reach the height, this point. Okay, and you have to find what is this height. You can find the height, you can find from the balcony, both way. Okay, so let's say this height is h from the ground. Okay, the height from the ground is h, and from the balcony it is 100 minus h. 100 is bigger, obviously. So suppose the ball meets at a height of h and after time t. So now we have to see that the velocity of this ball is not given. If you see in the question, the velocity of this ball is not given, but it is mentioned that it reaches this balcony. The ball reaches this balcony. Now what we will be doing, we will be using a simple conversion to find the velocity first. Okay, so if you can do that, that will save some time. Otherwise the problem can be solved in other methods also, but one small help from work energy power will help us to solve this question faster. Velocity is not given, but it says that it reaches that 100-meter high. Okay, so that means what? That means at this 100-meter height, what is its potential energy? Potential energy is mgh, mg100, and it's when it started, its kinetic energy was half mv square. Okay, and because energy is conserved, they should be equal. From conservation of energy, kinetic energy should be equals to potential energy. Okay, because if you throw something, when it reaches the top, at the top position, it is completely potential energy, and when you are throwing it from the ground, its total energy is completely kinetic energy, right? We have seen that when you are dropping a ball at some height. Okay, that derivation, by the way, we will be doing in our model paper solution. So be prepared for that. Model paper solution is also we are going to do, so don't miss out on that. Now, so m cancels and we get half v square equals to 10 into 100. Okay, or v square equals to 20 into 100, or v equals to 10 root 20. Now we can keep it as v square, but we are for sake of mathematics we are leaving it here. Don't try to simplify it, it will be automatically be cancelled, or you can calculate it. Okay, now you have to find the time. So the ball rises to say some height small h, and other ball falls by a distance of 10 minus h. Okay, so this ball is falling with the gravitational acceleration. This ball is moving against the gravitational acceleration. Okay, so this ball is moving against the gravitational acceleration. This ball is falling with gravitational acceleration. So what is the distance traveled by the ball on the balcony? So the ball on the balcony, the distance traveled is 100 minus h equals to 100 minus h equals to half g t square. Okay, so this is the distance traveled by the ball on the balcony. What about the distance traveled by the ball from the ground? Distance traveled by the ball from the ground, h equals to vt minus half gt square. Same thing. Okay, half gt square. because the ball is moving against the gravity, so minus half gt square. Time should be same for both the balls, right? Because they are meeting, so they are one ball is thrown, one ball is thrown up, one ball is dropped, so both ball are moving simultaneously and they are meeting at some height. At that height the time should be same. Now only thing remains, you have to add them. So once you add them, what you get? 100 minus h plus h equals to Vt. Okay, plus gt square minus gt square cancelled, and V we already know, h obviously cancelled, so you get Vt equals to 100, or T equals to 100 divided by 10 root of V, that is 100 divided by 10 root 20. Okay, so this cancels and you get this as square root of 5. You can check this out, it will be square root of 5 second, 2 point something. Okay, so this is the value of the time. Now once you calculate the time, you also have to calculate this height. You have to calculate this height. So for that you can go back to either this equation or that equation. Let me use this equation because a lot less to calculate here. If you use this, you have to calculate Vt, then gt square, that might be slightly complicated. So let us go back to this equation. So 100 minus h equals to half, g is 10 and t square is 5 root 5 whole square. So that's why we have taken this value. So 100 minus h equals to 5 into 5, that is 25. Okay, so h equals to 100 minus 25, that is 75 meters. Okay, so the ball meets at a height of 75 meter and at after time root 5 second. Okay, so root 5 second at a height 75 meters. So remember, it is height, not from the top, so that's why you have to mention at a height. Okay, if you don't mention that, your marks can be deducted. Okay, easy problem, but little bit more practice you require to solve such questions. Now let's move on to question number 4. The resultant of two forces acting at an angle of 120 degree is at right angle to the smaller force. If the greater force is 80 Newton, find the smaller force and the resultant. Very interesting question. So here we have two forces and the angle between them is 120 degrees. So 120 degrees means something like this. So suppose this is our vector A, this is our vector B. The magnitude of B is given as 8 Newton, and what is mentioned that the resultant, so this angle is 120 degrees and the resultant makes an angle of 90 degrees with this. So if you draw a parallelogram, you will get this. Okay, so parallelogram law of addition, so you will get this as 90 degrees and this is the resultant vector. What you have to do, you have to find the magnitude of A, magnitude of R. Okay, so these two things you have to find. Now how to do that? So bigger angle is given. We know that for two vectors the angle is given by tan phi equals to B sine theta by A plus B cos theta. Okay, so basically what happens is that the side with which you are measuring the angle, that comes only once. The other side which is with which you are not measuring the angle, that comes twice with sine and cos. Okay, so this is how you can remember. Now tan phi, here phi equals to 90 degrees. So tan phi equals to infinity, right? So infinity means what? Infinity means it is actually 1 upon 0 or some number divided by 0. So that means it is only possible this becomes 0 when A plus B cos theta must be equals to 0. Theta is, what is theta? Theta is 120 degrees. Okay, so only way the phi can be 90 degrees when the denominator is 0. Okay, slightly tricky, conceptually tricky, but mathematically not difficult. So A plus B cos theta must be 0 because tan phi is 90 degrees. Okay, now we have to put the value. So A plus B cos 120 degrees equals to 0. Now cos 120 can be taken as minus cos 60 or minus sin 30. Both way it is possible. So A plus B, I am taking sine, so minus sine 30 degrees. Okay, we know the law of complementary angles, right? Here it will be 90 plus 30. 90 plus 30 means minus sine 30. Okay, so now we have to put, so A equals to B sine 30, right? So B will be equals to, so A will be equals to, obviously B is given by 8 Newton and sine 30 is half, so that is 4 Newton. Okay, so A is 4 Newton. So value of A is now calculated. Now we have to calculate the resultant. What formula do we use for resultant? Very simple. Resultant is given by square root of A square plus B square plus 2AB cos theta. Okay, so that means A square is 16, B square is 64 plus 2 into 4 into 8 into minus half. I am just taking one step, taking one step down, because minus sine 30 is minus half, cos 120 is minus sine 30, so I am just skipping one step over here. And because we have solved once and we know that it will come out eventually as minus half, so I am putting that minus half. Okay, so this cancels, 2 cancels, and we get 70, 80 minus 32. 80 minus 4 8s are 32, so that will be 50, 48. So it will be square root of 48, approximately 7 Newton. Approximately 7 Newton, 6.9 Newton. Okay, because 48 is very close to 49, I am saying this is 7 Newton. So if you take the exact value, you will get 6.93 Newton. Okay, that is, obviously you are allowed to use small simple calculator where you can take the square root and you can calculate the exact value. Right, now let's move on. A football player kicks a ball at an angle of 30 degrees to the horizontal with an initial speed of 20 meter per second. Calculate A, the maximum height, and B, the horizontal reach by the ball. G is given 10 meter per second. Okay, so the angle here is given as theta equals to 30 degrees and horizontal initial speed is 20 meter per second. Okay, now you have to calculate the maximum height. Maximum height means h. H is given by v square sine square theta by 2g. Just formula putting and find the answer. As simple as that. So v square means 20 square, 20 into 20. Sine square theta means sine 30 whole square. Sine 30 whole square means 1 by 2 whole square. Okay, theta is obviously 30 degrees. I have written it once. 2g, 2 into 10. Okay, g is 10 given here. Okay, now what? Now just simplify. It cancels. We get 20 into 1 by 4, that is 5 meters. So maximum height is 5 meter. What about horizontal range? Horizontal range is given by r equals to, by the way, in the derivation I missed it. So horizontal range maximum at sine 45 degrees, sine 2 theta divided by g. Okay, v squared sine 2 theta by g. So this, not only the derivations but also the formula you have to remember. Okay, so v square is equal to 20 into 20. Sine 2 theta is sine 60. Sine 60 means root 3 by 2. Sine 60 means root 3 by 2 divided by 10. So 0 0 cancels, 2 2 cancels, and we get 20 root 3 meters. Okay, so horizontal range is 20 root 3 meters, and if you put the exact value, you will get 34.64. okay, it will come out to be 34.64 meters. Now remember, the unit is compulsory. The unit meter is compulsory in both cases. If you don't put the units, you lose marks. So whenever you are putting the formula, don't forget to put the unit at the last step, otherwise marks can be deducted. Let's move on. the ceiling of a long hall is 25 meter high. What is the maximum horizontal distance that a ball thrown with a speed of 40 meter per second can go without hitting the ceiling of the hall? So here we have a building, and you are saying that the height is given by 25 meter. The height is 25 meter. So how far the range can, the maximum range the ball can have with this height? We know that formula for height is given by v square sine square theta by 2g. Okay, and this height must be equals to the height of the ceiling. So without touching the ceiling means maximum height can be the height of the ceiling. Okay, so that is 25 meter. So 25 meter equals to v is given 40 meter per second. So 40 into 40 sine square theta, we don't know theta we have to calculate. Okay, or sine square theta actually we have to calculate, or sine theta, if you can calculate sine theta as well. Okay, divided by 2 into 20. Okay, 2 into 20. Now simplify, sorry, not 2 into 20, 2 into 10. Gravitational acceleration is 10 meter per second. Okay, so 2 cancels, we can cancel 2 more, and we get sine square theta equals to 25 divided by 80. Okay, 25 divided by 80. So sine theta is equal to 5 by, or we can even simplify this. We can even simplify this. 5 5s are 25, 5 1s are 5, and 5 6s are 5 16s are 80. Okay, so sine theta is root 5 by 4. Okay, so sine theta is root 5 by 4. What about cos theta? You can calculate cos theta as well. So cos theta equals to 1 minus sine square theta whole root. Okay, so that will be given by 1 minus 5 by 16, that is 16 minus 5 by 16 square root. 16 minus 5 is 9, so it will be 3 by 4. Okay, sorry, not 3 by 4, it will be square root of 11 by 4. Square root of 11 by 4. So cos theta is calculated, sine theta is calculated. Now we have to calculate the range. The range is given by v square sine 2 theta divided by g. Okay, now remember why we have calculated sine theta cos theta, because we have to eventually calculate sine 2 theta. Okay, we have to eventually calculate sine 2 theta. Okay, sine 2 theta calculation is very important, so we will do that, and then we will come back to our range calculation. Sine 2 theta equals to 2 into sine theta cos theta. Okay, so 2 into root 5 by 4 into root 11 by 4. Okay, sine theta is root 5 by 4, cos theta is root 11 by 4. So that will be square root of 55 by 8. Don't miss out on this 2. Okay, that 2 is also there. So now we will put the values. For v square is 40 into 40 into square root of 55 divided by 8, and then we have whole divided by 10. So 0 0 cancels, 5 8s are 40, 5 4s are 20, so 20 root 55 meter. Okay, so if you calculate the value, you will get 150.5 meter. Okay, 150.5 meter should be the answer. Now let's move on. A body of mass 8 kg is suspended by a rope of length 2.5 meter from the ceiling. A force of 60 Newton is applied on the body in the horizontal direction. Find the angle that the rope makes with the vertical in equilibrium. Neglect the mass of the rope. So again, interesting question. So the questions will not be very simple. Be careful. You have to solve a little tricky and difficult questions. You are now slowly, you are no longer part of class 10th. You are now in PU1. So PU1 question will be slightly tricky. So you have to practice them. Not super difficult mathematically or calculation wise, but criticality will be little bit difficult. Okay, so here we have a ball and you have applied a force in the horizontal direction. So what will happen if you apply a horizontal force? The string will bend like this. Okay, and the force on this direction is given 60 Newton. Now what else? So 60 Newton will be acting in this direction. Okay, 60 Newton will act on this. We have to draw the free body diagram basically. So what are all the forces acting on this? One force acting on this is mg, and there is a tension. Okay, you have to find this angle theta. Okay, the angle it makes with the horizontal. Okay, so if you can find that angle, you will be able to solve this. Now you can take two components of this tension, one component along this direction, okay, and that will be t cos theta. Why? If this angle is theta, then this angle will also be theta, and another perpendicular component which is t sin theta. Okay, now for vertical equilibrium, for vertical equilibrium, what happens is that the vertical forces must be equal. So t cos theta equals to mg, and for horizontal means this way. For horizontal equilibrium, we can say that t sin theta equals to the applied force F. Okay, now we have to find the angle. So basically, if you take the ratio, we get t sin theta by t cos theta equals to force applied divided by mg. Now obviously sin theta t cancels, sin theta by cos theta is tan theta, and that is equals to 60 divided by mass is 8 kg, and the g is 10, so they cancels and we get 3 by 4. So tan theta is 3 by 4. Tan theta is 3 by 4. So if tan theta is 3 by 4, then theta must be equals to 53 degrees. Okay, there are sorry, not 53, 37 degrees. Okay, 4 by 3 tan theta 4 by 3 is 53 degrees. Tan theta equals to 3 by 4 is 37 degrees. Okay, so the tan theta value is 37 degrees. The angle is 37 degrees. If you don't know that 3 by 4 is 37 degrees, then you can say theta equals to tan inverse 3 by 4. That is also accepted. Now this value is particular 37 degrees, 53 degrees. They are complementary angles. They are two special angles. Even though we only use in the table we use 0, 30, 45, 60 and 90. 37 and 53 are also important, and because those values can also be calculated. Right, so this is the angle based problem. Now let's move on to the next question. A driver of a car moving at 25 meter per second sees a child on the road 70 meter ahead and stops the car 20 meter earlier to the child. If the mass of the car with the driver is 1000 kilogram, calculate the force exerted by the brakes on the car and the time taken to stop the car. This is a very standard problem. Suppose you are the driver is traveling on a road. Okay, so this is the car Okay, so this is the car which is traveling at 25 meter per second, and he saw a child is on the road at a distance of 70 meter. Okay, but as soon as he applies the brake, the car stops 20 meter ahead. So 20 meter ahead of the kid, the car stops. So what is the actual displacement of the car? Actual distance traveled or displacement of the car is 50 meter only. Okay, 70 minus 20, 50 meter only. So actual displacement of the car is 50 meter. That is the main thing that you have to understand from this problem. 70, we are not going to use 70, we are not going to use 20, we are going to use 70 minus 20, that is 50 meter. Now next step is to calculate the acceleration. If we can calculate the acceleration, we can find the force. Force equals to ma, father equals to ma, right? Now what you have to do is you have to use an equation of motion. V square equals to u square plus 2as. Okay, v square is equal to u square plus 2as. Now this is for positive acceleration. In this particular case, when the car applies a brake, a becomes negative. Okay, because it's a negative acceleration or retardation. Okay, when you are applying a brake, the car is basically, what happens is that the car starts to slow down and stops, and at this position, so this was u, okay, this was u, at this position v equals to 0. Final speed is 0. When the car is coming to a rest, that means v equals to 0. So we have to put v equals to 0, and that is equals to 25 whole square plus 2 into not plus, sorry, minus. Why minus? Because acceleration is minus, into s. S is the distance traveled, which is 50. Okay, not 70, not 20, but 50. Now we have to calculate a. So 2 into a into 50 equals to 25 into 25. Right, 25 square, or a equals to 25 into 25 divided by 2 into 50. Now if you observe me, I am not just multiplying 25 into 25, 625, it is easy to calculate, but for each and every step, if you are using calculator, then basically you are wasting your time. So because anyway it will be simplified, so you get the acceleration is 25 by 4 meter per second square. So acceleration is calculated. Now we can calculate the force. So what is the force? Father equals to ma, our grandfather, Grand Newton told us. So father equals to ma, mass is 1000 kilograms, and acceleration is 25 divided by 4. So it will be 250. Okay, 250, right? Yes. So it will be 6250 Newton. The force that the driver applied, the brakes applied on the car is 6250 Newton. Now what else? Next you have to calculate the time taken by to stop the car. Time taken is easy. Again, one equation of motion, v equals to u minus simply at. Okay, again we are taking minus from the beginning. V is 0, u is 25, okay, a is 25 by 4, and time is t. So we get 25 by 4 into t equals to 25, or t equals to 4 seconds. Okay, 25 cancels, and we get t equals to 4 seconds. So correct answer is 6250 Newton. So this is our part A answer, and this is our part B answer. Clear? Let's move on. A machine gun of 15 kg fires 0.02 kg bullets at the rate of 10 per second with a speed of 300 meter per second. Calculate the force required to hold the gun. So you are basically firing machine gun. In the Dhurandhar movie, Ranveer Singh was firing machine gun, right? And the other person is getting hit by the machine gun. He was trying to hide. So what is happening here? When you are firing a machine gun, it appears very easy easy in the movies. movies, but actually in reality it is very, very difficult. When you are firing a machine gun is also applying a force back towards you according to Newton's third law of motion. And that's why when you are firing a machine gun, that force you have to supply from yourself, otherwise it will come back towards you and break your bones. So don't try to be a hero. Okay, that is only for movies. Now, so when you are firing a machine gun at the bullet obviously is very mass of the bullet is very small, the rate is 10 per second, and the speed of the gun speed of the bullet is 300 meter per second. That is the main thing that makes the difference. So what how to calculate the force? The mass of the gun is not important over here unless they ask you what is the acceleration of the gun. Okay, so you don't need to calculate the acceleration, so only force is required. So this is a very easy question. So what is the force required? Force required is mass of the bullet, okay, number of bullet per second times the speed of the bullet. So if you multiply these three terms, you can calculate the force. That's it. Okay, so basically mass times number times this gives you the momentum, and because the number of bullet per second is given, it is rate of change of momentum, which is the force. Okay, so mass of the bullet is 0.02, number of bullet is 10, and velocity is 300. Okay, now this is actually momentum, but because the rate of firing is given per second, this is also rate of change of momentum. Okay, only this and this gives you the momentum of one single bullet. So this and this gives you one single bullet. If you multiply the rate of firing with that, you get the change in momentum per second. Okay, so change in momentum per second is the force. So now you have to multiply. So 2.2, 10, 300. So 1020, 1020. So 30 into 2, 2 into 30, that is 60 Newton. Easy question. Okay, I don't think this question will come. I have taken this question from your model question paper. Now next, assuming the earth to be a sphere of uniform mass density, how much would a body weigh at a depth equal to 1/4 of the radius of the earth if it weighs 200 Newton on the surface of the earth? What will the weight of the same body at the center of the earth? Now last part first. Suppose this is earth. On the surface of the earth, the body weighs 200 Newton, and we are trying to find at a depth of 1/4 of the radius of the earth. Okay, so that means we are trying to find the weight at inside the earth. At the center of the earth, weight will be equals to 0. Okay, there is no force, r is 0. So at the center of the earth, weight of any object is 0. Mass is not 0, weight is 0. Now we know that from our derivation that gravitational acceleration at a depth is given by g dash equals to g into 1 minus depth divided by radius. Depth divided by radius. Right, this is the gravitational acceleration at a depth d. Now here depth here is r by 4, so we will calculate now how to calculate weight. For that you have to multiply mg on m on both sides. So mg dash equals to mg into 1 minus d by r. Okay, m is constant for all objects, so m you can multiply. And what is mg dash? Mg dash is the weight inside the earth, mg is the weight on the surface of the earth. Okay, and that is 1 minus r by 4 by r. Okay, d is given r by 4. Now what is the weight on the surface of the earth? Weight on the surface of the earth is 200 Newton, and that will be equals to 1 minus 1 by 4, that is 200 into 3 by 4, so it will be 50. So 150 Newton. So 150 Newton is the weight at a distance r by 4. Now at the center, what we can say is that depth itself equals to r. So we can say that w double dash equals to w 1 minus r by r. So it will be w 1 minus 1, that is equals to 0. So weight at the center is 0. So 150 Newton and 0. Next, a raindrop of mass 1 gram falling from a height 1 kilometer hits the ground at a speed of 50 meter per second. Calculate number 1, work done by the gravitational force and work done by the unknown resistive force, given G equals to 9.8 meter per second square. So in this problem we will be using 9.8 meter per second square, not 10 meter per second square. Okay, so we have a raindrop of mass is 1 gram and it is located at a height of 1 kilometer. So before fall, what is the gravitational potential energy of this raindrop? Gravitational potential energy is given by mgh, right? M is 1 gram. 1 gram means 1 into 10 to the power of minus 3 kilograms. 1 gram equals to 1 into 10 to the power of minus 3 kilograms. Okay, G is 9.8 and height here is 1 kilometer, that is 10 to the power of 3 meter. 1 kilometer means 1000 meter, 1000 meter means 10 to the power of 3 meters. So this is the gravitational potential energy. Energy's unit is joules. So 10 to the power of minus 3, 10 to the power plus 3 cancels, we get 9.8 joules. Now from work energy principle, okay, from work energy principle, the work done by gravity must be equals to its gravitational potential energy, that is equals to 9.8 joules. Okay, so 9.8 joules is the work done by gravity. Okay, whatever is gravitational potential energy, gravity has to do the equal amount of work. Okay, now this is the answer for part 1. What about part 2? Part 2 is very interesting. So here, when the raindrop reaches the ground, just before touching the ground, the speed of the raindrop is 50 meter per second. So what is the kinetic energy? What is the kinetic energy of the raindrop? Kinetic energy just before touching the ground is given by half mv square, that is equals to half. Mass is 1 gram. 1 gram means 1 into 10 to the power of minus 3 and v square means 50 square, that is 50 into 50. Okay, so let's calculate. 1 2 zeros, 10 to the power of minus 1, so half into 5 5s are 25 divided by 10, so it will be 2.5. You can use a calculator and calculate it, no issues. 2.5 divided by 2, that will be 1.25 joules. So it started with the energy of 9.8 joule, that is the work done by gravity, but when it reaches the surface, only 1.25 joules energy left in it. Only 1.25 joules of energy left in it. That means the remaining energy is actually spent doing the work against the other resistive force. Okay, work done by the unknown resistive force must be equals to the work done by unknown resistive force must be given by the potential energy minus kinetic energy. Whatever is the difference in energy, that energy must be done by the unknown resistive force. Okay, and that is in the opposite direction actually. So 9.8 minus 1.25 and you will get this as 8.55 joules. Okay, so 8.55 joules is the work done against the resistive force. Okay, work done against the resistive force 8.55 joules. Now next, a pump on the ground floor of a building can pump up water to fill a tank of volume 30 meter cube in 15 minutes. If the tank is 40 meter above the ground and the efficiency of the pump is 30%, how much electric power is consumed by the pump? So here, suppose you are staying in a two-story building. This is your building. Okay, now here we have a water tank. The volume of the tank is 30 meter cube. Okay, now the height of this tank is, the average height I am taking is given here 40 meter. So when you are pumping the water from ground floor to this tank, what happens is that basically you are giving the water potential energy. Because of that potential energy, it is being stored at that tank. So we have to find the potential energy of the water. So if we can find the potential energy of the water and each second how much potential energy gain is happening, we can find the power, okay, the actual power that is being delivered by the pump, and then we can calculate the electric power. Electric power is more than that of the pump is supplying, because pump is only 30% efficient. So first we have to find the energy. What is potential energy? Potential energy is mg into h. Potential energy is mg into h. Now what is mass? Mass is given by rho into volume. Rho is the density of water. Normally in SI unit, density of water is 1 kg per meter cube. Standard density we will assume. Okay, this is the standard density of water. So we will put that m equals to 1 into 30, that is 30 kg. So mass of the water when the tank is full is 30 kg. So what is the potential energy? 30 kg into gravitational acceleration is not given, so we can take 10. Height of the tank is 40. So it will be 312 into 10 to the power of 3. 1, 2, 3 zeros. Okay, so this is the potential energy of the water, right? So this into G. G I have taken 9. Okay, 10, no problem. So this is the potential energy of the water. Now it is happening, the time is taken is 15 minutes. So what is the power? What is the power of the tank? Power of the pump. Power of the pump is given by the potential energy divided by time. That is 12 into 10 to the power of 3 divided by 15 into 60. Okay, 15 minute means how much second? So this is the power, and unit of power is what? Joules per second or watt. Okay, so this is the potential energy in joules. Now what? So we have calculated the potential energy, we have calculated the power. Now this is the power of the pump. Now the energy supplied by the electrical connection, suppose the energy supplied by the electrical connection is E, then that is the power of the pump. The question is not the power of the pump, the electric power you have to calculate. Okay, power of the pump is only 30% of the energy supplied to it. Suppose you are supplying 100 watt of power to the pump. Pump is utilizing only 30 watt. Remaining 70 watt it cannot utilize. Okay, that is the efficiency problem. Every device have a efficiency issue. Okay, so point remaining energy is being converted into heat energy, sound energy, etc. Okay, so power of the pump is only 3%, only 30%, that is 0.3. 30% means in fraction it will be 30 by 100. So it will be 0.3. Remember these kind of small tricks in future when you are attempting any competitive exam, that will be very helpful. So E equals to P by 0.3. So you have to calculate this one. So this will be 12 into 10 to the power of 3 divided by 15 into 60 into 0.3. Okay, so it will be I have made somewhere one small mistake. Let me check. Yes, so density of water is not 1 kg. Sorry for my mistake. It will be 10 to the power of 3 kg. Okay, so that's why there is 1 10 to the power of 3 less. sorry, so it will be 10 to the power of 3 kg. Okay, and it will be overall, it will be 10 to the power of 6. 10 to the power of 6. Now, so if you calculate this, you will get the answer as 43.56. 43.56 into 10 to the power of 3 watt, or 43.56 kilowatt. Okay, 43.56 kilowatt. Don't make the mistake like I have made. So density of water is 10 to the power of 3 kg per meter cube. Now next question. The base of a copper, I think this question is taken from your model paper. We will be solving again. The base of a copper boiler is 2 centimeter thick and has an area of 0.01 meter cube. The steady difference in temperature between its surfaces is 5 Kelvin. Calculate the mass of the water that evaporates in 1 hour. Given the thermal conductivity of copper is 385 watt per meter per Kelvin and the latent heat of steam is 2.2 into 10 to the power of 6 joules per kg. So this formula we will be using to solve this question. This formula you have to remember. Okay, so here K is the conductivity, A is the area, delta T is the difference in temperature, D is the thickness of the boiler. So what is happening here? We have a pot where the water is being boiled. Okay, so this is the thickness D. Okay, the area of the surface is given by A. The conductivity of the material is K. So the heat that you are supplying is this. So from there you can say this is the heat supplied, and the heat that you are supplying, that will be utilized to convert water into vapor. So that should be equals to mass into latent heat of water. Okay, so from this formula you can calculate the mass. So mass of liquid that gets evaporated is given by K A delta T by D into latent heat L into time T. Okay, so the conductivity of copper is given 385. So this is just a formula based question. So area is 0.01 meter square. The temperature difference between these two phases is 5 Kelvin. Okay, and the time in 1 hour, 1 hour means 60 minutes, 60 minutes means 60 into 60 seconds. So this is the time divided by the distance between or the thickness of the copper boiler is 2 centimeter. Okay, so 2 centimeter thick, so 2 into 10 to the power of minus 2 meter. Okay, and the latent heat of boiling is 2.2 into 10 to the power of 6, and the answer will be in kilograms. So as you can see, the answer not super simple, but you can still solve it. If you solve it, you will get 1.575 kg. 1.575 kg. So it requires some patience to simplify this equation. 10 to the power of, you should calculate first, 10 to the power of minus 4 should be go up, then you simplify the remaining values, and then you will get whatever value divided by 10 to the power of 4, you get the answer. Okay, now next question. Last question of the day. A string of 1 meter long is under a tension of 440 Newton. If the fundamental frequency is 100 Hertz, find the mass per unit length of the string. What is the mass of the string? So again, the fundamental frequency of a stretch string is given by 1 by 12 square root of T by mu. T is tension and mu is the mass per unit length. So we are trying to find this mass per unit length mu. So how to do that? So fundamental, or one other way is, one more formula that you may have seen, 1 by 2 square root of T by mass into L. Okay, so that is also fine. If you can calculate mass and then divide it by the length, that is also fine. Actually, what happens if you take mu, then one extra L comes out and that can be taken out of the square root. That's it. Both formulas are same. If you are using this formula or that formula, both formulas are same. Okay, now let's see. So here tension is given as 440 Newton and frequency is given as 100 Hertz and length of the string is given as 1 meter. Okay, so you can put it over there in this equation. I am using this equation. So from here you can say F square, or let me put the values, then we can do the square and not square. Okay, so we get 100 equals to, so from equation 1, so 100 equals to 1 by 2 into 1 into square root of tau t, tension is 440 divided by mu. We are trying to find mu, right? Now do the cross multiplication. We get square root of 440 divided by mu equals to 2 into 100, that is 200, right? Cross multiply. Now take square on both sides. 440 by mu equals to 200 whole square, or mu equals to 440 divided by 200 square. Again you can use a calculator to calculate the value. What is the mass of the string? Mass of the string is mu into length, right? So mass per unit length into total length. Total length here is 1 meter, so mass will also be mu, but it will be in kilograms and this will be in kilograms per meter. So unit wise they will be different, value wise for this problem they will be same. So if you simplify, you will get 0.01 kg per meter is the mass per unit length, and mass is 0.011 kg. Okay, so remember this. So answer wise, because the length is 1 meter only, both answers should be same, value will be same, unit will be different. So unit difference also you have to take care of, right? So this is the end of today's lecture, but this is not the last lecture. We will be back with obviously the model question paper, also the most expected fixed questions and their solutions. Everything will be discussed in our channel. So if you have not yet subscribed, don't forget to subscribe. I will see you in a future video very soon. Till then, bye.